Now that our force field is up and running, we need some kind of way to tell visually how much health it has left. And we want the player to be able to do this from in-game because the player won't actually have access to all this stuff over here. They won't be able to go over here and select the force field and see how much health it has left. And even if they could, that wouldn't exactly be a very good option, because then you have to stop playing just to check your shield health, and by the time you've checked it, it's already gone down. So the way we're going to do this is we're going to have the shield change colors. It's going to start out being this nice blue color you see here, and then over time it's going to transition from blue to purple to red, and once it gets to red, you know it's close to breaking. So let's start off by opening BP Force Field. We're going to start off by working off of event begin play this time instead of begin overlap. The first thing we want to do is we want to make another variable. We'll make a variable called max health and set that as an integer. Right, so after event begin play, we'll drag in max health, click set, and connect them, and set max health equal to health. You'll see why we're doing this in a moment. Actually, I just realized I don't know how to do this. This equals to max health. So after event begin play, we'll drag in max health and click set. Connect white to white and set max health equal to health. The reason we're doing this is so that the game can track what percentage of our max health we have left. The way that this shield is going to work, as your shield takes damage, it will slowly become less blue and more red. If you remember in the last video, I talked about the RGB color system a little bit. The less blue it becomes and more red your shield becomes, the more it'll turn to this purple kind of color. Once it's purple, if the blue keeps coming out and the red keeps going in, eventually your shield will become red. Once we've got that, we'll want to drag off of this white here after set and type in create dynamic material instance and choose the one that says sphere. A dynamic material instance basically just gives our code a way to change our material while the game is running. Changing things like how metallic it looks or how brightly it glows, or in our case, the color. Now, we can't really do anything with this material until we make it a variable. So we'll right click on a return value and click promote to variable. And we can just name this variable mat, M-A-T, short for material. This allows us to use this material instance multiple times. So the next thing we're going to do is something we actually haven't talked about yet, which is we're going to make a function. So click on plus function here, and we'll name it calculate, if I can spell, color. What exactly is a function? A function is basically the same thing as an event. There's only three major differences. Number one, certain events get called automatically. This is impossible for functions. Functions cannot be called automatically. Number two, for whatever reason, you can't use a wait block during a function. You can use one in an event, but not in a function. And number three, and this is why this particular function is going to be important, you can get information back from a function. You can't do that with an event. That's why we're using a function instead of another event. Now, what's the information that we want to get out of this? Well, we want to get the color that our force field is supposed to be. So to do that, we're going to click on outputs. Inputs are extra information that the game needs before this function can run. Outputs are the things that you find out from running the function. So we'll click new parameter on outputs, name it new color, and make it a linear color. Right click on new color and click split struct pan. The reason we split this up is so that we can access the red, the green, the blue, and the alpha individually. Alpha is not going to change. Alpha is always going to be the same. We have our alpha set to 0.4, so set alpha to 0.4. Or new color A to 0.4. Then we'll spread these way out. And in here is where we're going to actually calculate what color this is supposed to be. We're only going to be changing the red and the blue values. Our green is going to stay at 0 because you don't need green to make purple. So what we'll do is we'll drag in health, click get, drag in max health, also click get, right click and hit slash. Slash is for division, and we'll do float divided by float. The reason we're doing float divided by float instead of integer divided by integer is so that we can get a more accurate color. We'll drag health into the top slot here, drag max health into the bottom slot, and what do we have? What is this number? Well, this number is the percentage of our shield's health that's remaining written as a decimal point. So some number between 1 and 0, just like our RGB values have to be. 1 being 100%, 0 being no shield. If your shield has 5% health remaining, this number will be 0.05 because that's 5% written as a decimal. This is a number that we want to get. This is a very important number because this number is how blue our material is going to be. So we'll drag off of this dot and connect that to new color B. But how red is our material going to be? Well, we want our material's redness to be the same as the percentage of our health that is missing. So blue is how much of our health is remaining, red is how much of our health is missing. So to do that, we're just going to right click and click minus, and click on float minus float. We'll do 1 minus this same number and drag that into new color R. So this number is the percentage of our health that's remaining. This number is 100% minus the percentage of our health that's remaining, which is however much of our health is missing. If we have 75% of our health left, 100% minus 75%, that's 25%. So it'll be 25% red and 75% blue. This is also why the shield will be turning to purple in between being blue and red. As the shield takes damage, the blueness goes down and the redness comes up. Eventually, they'll get to a point where they're close to the same level, and at that point, the shield will turn purple. It's not blue, it's not red, it's purple. So what do we do with this? Well, let's go back to the event graph here. So if our shield has run out of health, then we want to destroy the shield. But if it hasn't, then we just want to change the shield's color. So I'll drag that up to give me a little bit of room and drag off of false here and type in calculate color. And that's actually this function that we made over here. Alternatively, you could just drag in the function and connect white to white. Either way works just fine. I just wanted to show you both. So once we've got that in, we'll drag in matte, click get, drag off of matte, and type set vector parameter value. What does this block do? Well, it does exactly what it says it's going to do. It sets the value of a vector parameter in this material. Parameter name is the name of the parameter, and value is the new parameter value. This is why I made such a big deal about the way we spelled the word color in the last video. We'll change the parameter name to color, written exactly the way we did it in the last video. If there's any discrepancy at all, if your capitalization is different, if your spelling is different, if you misspelled it in one spot but not the other, this will not work. This has to be exactly the same. That's why I made such a big deal about it in the last video. So what we're going to do, just connect calculate color to vector parameter, to set vector parameter value, and connect new color to value. We'll compile, save, and that should do it. Yeah, and you can see now as the bots hit this shield, it's slowly fading to a purplish color, and now we've gone past the purple, we're getting into the red. And now that we're at a dark red, the shield has been destroyed. So that's that done. All of our assets have been created. So in the next video, we will start putting together a scoring system.